Okay, so, we did some of these before Thanksgiving break, the Friday before. I think we did 2 of them, maybe just 1. So it was
Just one.
stupid half-day crunchy things. Okay, so homework tonight, I'm asking you to do, I think, the last 2 problems on here. But looking at the calendar, we have finished chapter 5 in material. And I thought it would be really kind of rude, especially with Italian trip just getting back, to be like, hey, welcome back, have a test. So, stalling as much as I can. Test is Thursday. So today, tomorrow, and Wednesday are, hey, remember chapter 5? And you will go, no, I do not. Could you answer this question? But you guys need to come in with, like, any of the homework. What's your question? The beginning was like LRAM, RRAM, MRAM kinds of things. When is it an over or under approximation? Finding, is it increasing or decreasing? That's what the rectangles, trapezoid rule needed, concavity, and checking that. And then there was actually integrating, like undoing power rule, or knowing how to integrate this was just, hey, wait a second, whose derivative is 1 over x? Because if you did raise the power, divide by the new power, -1 goes to 0, divide by 0 is not allowed. Oh, so whose integral is this?
Natural log.
Natural log. Jail bars plus c. Why plus c? There were no numbers on it. If there were numbers on it, no more plus c. And first fundamental theorem of calculus was, or second, doesn't matter, one of them was integrate, now plug in the top number versus minus plug in the bottom number. And on an AP exam, they'll never leave this answer like this. Subtraction becomes a fraction. They would have that. And just to irritate you, I don't think they would do this. But that negative out front means to the -1 power, -1 power, it flips the whole thing. Ben, just to piss you off, you personally. So, so that was one part of the fundamental theorem of calculus. The other thing that we did was stuff like that. What is the derivative of sine? Derivative of the integral of sine, I should say. Do you remember?
Cosine?
Okay, all right, so whose
Negative cosine.
whose derivative is positive sine, negative cosine? So that's integrating and evaluating from, sorry, not cost, cosine of t. So this is integrating. But I said, I don't want the integral, I want derivative. So what's the derivative of negative cosine?
Sine.
Positive sine. What's the derivative of cosine of 0? The derivative of a constant?
0.
0. So there's my derivative. Hey. That was the relationship, yeah.
Wait, why isn't it negative sign? Because isn't the derivative cosine a positive sign? So if it's negative, it should be.
Because I'm not doing the derivative of positive cosine, I'm doing the derivative of negative cosine.
Yeah, but what I'm saying, isn't the derivative of positive cosine positive sine of x?
No.
Oh wait, maybe.
The ones that
oh,
begin with-
wait, the derivative of sine is cosine. The derivative of cosine is negative.
Yeah, all
I mixed them up.
the derivatives of the c
Yeah.
guys are all negative and contrary.
Oh, okay, I messed it up.
Okay, so that was, the derivative of the integral is just the stuff inside, but then there was this irritating wrinkle. The irritating wrinkle is, Okay, well, if I did from tan x to x, this is negative cosine of tan x. Now the derivative of this would have been, derivative of negative cosine is positive sine, leave the inside alone, but now chain rule, derivative of tangent, secant squared. Right here, derivative of cosine, positive cosine is negative sine of x, chain rule derivative of x is 1, so I would have gotten this gross business. So the shortcut was the derivative of the integral is sine of stuff minus sine of stuff. Top part plugged in, chain rule, secant squared. Bottom part plugged in, chain rule, derivative of x is 1. So that's a reminder of the two fundamental theorems of calculus. Yeah?
Yeah, I saw there's something in the textbook also about like if you have a variable on the bottom, like to get to go to the top. So,
Okay, and the example I just had a variable in both, so you're kind of screwed with that. But if it was, we'll stick with sine. I can change the bounds, I can trade them by doing what?
oh.
Add negative sign.
I can have the negative on the outside of the bar, inside of the bar, whatever. If it's just a number, it can flow through it. So whose derivative is negative sine, positive cosine? But in this case, it doesn't matter. I'm doing the derivative of the inside, so that's negative sine, plug the top one in, chain rule derivative of x is 1, minus sine of 3 times the derivative of 3, just a constant, it's going to be 0. I'm not even going to write it. There it is.
Right, and so then if you have like two variables, like should you put the one on the top with the higher degree?
Doesn't
Or
matter.
It doesn't matter.
Hang on. As it was without trading it. Without trading it, plug in the top one and then chain rule, derivative of 3 is 0. Okay, so 0 minus sine, plug in the bottom, times the derivative of that, I still get negative sine x.
Right.
Okay. All right, so today I wanted to do more of these practice, AP practice questions. Let's see. Can you do the second one that's on there? They generally take, they say to give you 15 minutes for these, but these are slightly quicker. This is one of the quote fast ones, non-calculator. So I'm gonna give you like 10 minutes and then we'll go over it.
Yeah, but you can also think of like G as its own graph, because there's a variable in here that like makes it a graph. It's almost like a value. Depending on the mix, you could get a different line. Because it changes sign. Changes what would it change sign? Yeah, and positive endpoint.
Put that.
Just positive. It's not even 5 negative, just 8. So that's why it's positive arrow.
Is changing sign going to have to it's a constant that it changes.
It's going to be difficult.
Wait, no, it's not actually, it's the we should think about it.
Like, which is just every corner of the sign changes anyways. So you just say, this is.
Is G prime of X, is that correct? Because of the
Yeah, not necessarily.
Oh, yeah.
So these. That's a corner.
That's a corner.
Still.
Undefined.
So like. This guy's got.
Yeah.
The second derivative is undefined, is that also an inflection point? If it changes
No.
sign.
Yes.
Was it 3? Yeah, no, it doesn't.
So, critical points, first derivative, 0 undefined, period. Inflection points, second derivative, 0 undefined, and the derivative changes sign.
Okay.
So there's an extra condition.
It's undefined.
Yeah.
It's the corner.
No, it's not, because this is the derivative. It is, bro.
So this is
Is that not?
Because the problem
Because G is the integral, so G is just gonna be this graph.
You right.
So.
But I don't know how you find
We should probably guys listen to
How do you
Would
find?
it just not be absolute value?
No. It's because you need to find the line.
That's not too hard, because pi is going to be.
No, the x value is
2
3.
pi
We know
plus-
the x value is 3. It's x
2
minus 3.
plus 2 pi plus 1. Because 2 pi is the circle. Higher square root of material square. 2 squared is 4, so.
We're gonna have to
the
find
three.
x.
It's like its whole function.
Yeah.
Third corner. I see. You get this then for the whole thing.
And that's just x minus 3, right? Equals negative x minus 3. What's right in the equation?
Do you just like find the point? So you.
But with the slope.
It's negative 1.
So are you guys
Yeah.
done already, or?
Like maybe 3 or 4 more minutes.
Yes, that's what I got for
No.
I didn't want
I
it
was
because
on that road.
pi
No,
minus
but
1
that's-
equals
No, but
negative
that's
1
F times F minus
x minus 3.
I mean, no, this is like, this is like, this is like work graph. This is like work.
No,
Just put the slope changes.
Well, I guess like the
Yeah, exactly.
graph.
Yeah, so
So
if x
two.
equals 0.
You'd find where it
Yes.
lands.
Is it just like
Random
half of-
question, is anyone in here on the baseball
No, it's
team?
not. Slope, not capping,
It's
yeah.
the slope, because the gap.
They really just.
Why?
But I think it should be equal 1, because like, even if you do like a square, it's like half.
Just leave it
half.
at
0,
Zero.
so 3.
And like if you do the base of the height.
Yeah, there's no because, and that's function of x, which is.
It's undefined, which is still
Oh, shit, yeah.
quite an function. Yeah.
Wait, oh,
G
yeah.
double is the less than. Wait, no, change sign.
And you're done?
Yeah, I think.
So often the fundamental theorem of calculus is a faster question. Hopefully, it's all good. So I'd like to talk about it. So as I try to get you guys to do, label what you're doing. What is g of 3? Well, here's g of x. So g of 3 is the integral of f. How do I evaluate integral? By looking at a graph, I find the area. So maybe I'll color in the parts that I'm looking for. So what is the area of that?
5 minus 1 half.
Okay. This part, a quarter of the circle with a radius of 2, so 4 pi divided by 4 pi. And then the area in this triangle, 1/2 base times height. So it's 1/2 times 1 times 1. And he said minus. Why is it minus?
It's below the x-axis.
Below the x-axis. All right, perfect. That's 1 point. These are worth 9. That's one of them. Read the answer or the question carefully. Open interval. They're not asking you to check the endpoints, so don't waste your time.
I told you, bro.
Where does it have a relative maximum? To find a maximum, what do we do, Constantine?
Well, don't you need like find the relationship that g prime of x equals f of x?
Okay,
So when f of x equals 0, it goes from positive to negative, then that would indicate there'd be a maximum there.
so all the things you just said. So he said to find maxes and mins, we do the derivative. What's the derivative of g? Well, the derivative of an integral is just the stuff inside. With x plugged in times derivative of x was 1, so f of x. And then minus f of 0 times the derivative of 0, which is 0. We're not even going to write it because it's going to confuse us. It's just f of x. And then he said max happens when maxes happen when the derivative changes from positive to negative. Don't just tell me it changes sign, because if it changes from negative to positive, then that's a minimum. So I need it in this direction. So, Felipe, when does that happen?
2.
So, grading rubric. This was 1 point to get all of that. This is 1 point to say the connection. The derivative of this is that. And then, why is it a maximum? Because the first derivative changed from positive to negative. 1 point for this. Where did it happen? 2. X equals 2. Don't give me y values because they don't really make sense. Because the y value here is the slope. Question or yes?
Yeah, so if we have like the connection between like g prime of x equal to f of x in like a later section, that's, does that count like? or-
It should,
Because like I didn't like specifically like write that out for B, I wrote it for like, for part C, but I still have it written
okay,
down.
so they have changed their policies on this. It used to be, put that on paper anywhere, and it's good. Last year, they told me that it needed to be written per section that students needed it. And I was like, no, it's written. They said this already. Like, I argued with it a lot.
It's right at the top. It's right. It's crazy.
So they changed their policy last year, and I complained a lot about it, and was like, no. Felipe clearly stated his knowledge and brilliance in part B, and then used it again in C. Screw that. I was angry. Sometimes I got overruled, but sometimes I was a persistent enough pain in the butt that I won. Okay. But it all depends on their mood and mine. Okay, this one. Write an equation for the line. They are, quote unquote, trying to help you. Write the equation of the line at 3. Part A, you found the coordinate, don't find it again. So it's y minus parentheses, the y value without the parentheses, this is wrong, equals slope times x minus the x value. The only thing to this was now find what is the slope, what is g prime of 3. Well, g prime of x, Constantine told us, is f of x, so all I gotta do is look for f of 3. It is the only coordinate that they're telling me. They're like, just so you don't claim like, oh, I couldn't read the value. I will tell you the value of that coordinate. There it is. Okay. Part D, Again, open interval, find the x coordinate of each point of inflection. Point of inflection, when do inflection points happen?
When, the concavity or second derivative is at 0 and changes sign.
Okay, yeah, okay. So inflection points are when the second derivative is 0 or undefined and changes sign. How do I read the second derivative of g off of a graph of f?
First derivative of f.
That's facts.
Okay, g double prime is the slope of f. So where the slope of f changes sign, I've got an inflection point. Sophia, where are my inflection points?
I said at 2 and, or, yeah, no, not at 2, at 3 and at 0.
And specifically not at 2. At x equals 2, the second derivative is undefined, but it doesn't change sign. Okay? So this grading rubric is old, it would be different now, but this is what they said. Oh, they don't put point counts. And there are a number of different ways that you could have given your justification for the inflection points. But that's what they say. Cool? How you doing? First period was really rusty. They're like still cloudy, still had like big fat meals weighing down their brains. This one, I hate this one. If we have time, we'll look at it, but, and just to show you, this is 2022, looks a whole lot like what we just did. It's just reflected and sort of shifted. But, and they ask this one, so they're given more information. They ask for 2 of the coordinates, and now it's on the open interval, find the inflection points, but on the closed interval, find the absolute minimum. Looking at this quickly, where is the absolute minimum? Felipe, it says 4. Why?
Because it's where the sign changes from negative to positive.
Okay. And why is it not at the endpoints?
Because it's a good question. Normally endpoints are in the negative region.
Okay.
That's what I was talking about, yeah.
We're looking for absolute, this one said minimum. Integrating, starting at 0. Again, they're asking for the endpoints in this first question, or not endpoints, but close. The integral at 0 is 0. And then we went backwards, we went backwards, we went backwards. And then we went forward. Is the area of that triangle that would have fit in here, that trapezoid, whatever. I accumulated more area backwards than forwards. So quickly, you could just see that. Justification-wise, I can't use that. It would be what you said. Well, the derivative changed from negative to positive here, but then you would have to do some kind of analysis at the endpoints. So just after a while, these look repetitive. And the goal is to show you as many of them as possible so that when you do them, they're not so bad. I believe this is the next one in the packet to try. So skipping the wiggly one with gut on it.
Yeah.
Is this the next one on there?
Yeah.
Okay, so give that one a try.
triangles cancel out. These two triangles cancel out. Both of these are one half, so we just check that.
Days with smart shirts.
Just one triangle, which is 4, 2, 4, 1, 3, 1, so let's see. This one.
Yeah. With Monica, who's all of them right now. Do you have the AP problems packet from like the week before break? Okay, that's what we're working on now.
It's 1, 2, X not 2 G of X. It's tricky. The last question just actually asked for a point there, just ask itself, if those listed, what actually do with that? This is X equals 2, this is still negative X equals 10, it would be X equals 1. It doesn't have to be just it's not. It's the slope. So it just that's the question.
You guys are done again.
This one was not the longest.
Yep.
Oh, yeah.
Okay, it's on that table somewhere. Thank you.
We want to go from negative to positive, so that's what Netflix is. Here's a negative. Well, you find that the absolute maximum So I haven't learned anything the average. It's nothing, and then starts, and it just goes straight up, so that means it had to be low at that point.
Well, 4 is a low point.
Yeah, I understand.
Then you're gonna be like, this is
Okay, G of 4. How do I find G of 4?
G of 4 or? Oh, that, yeah, find the areas of the trapezoid and the triangle.
Okay, be careful. It's integrating from 1 to x. So G of 4, starting here, find that. But then if you look at it, that much above, that much below, they cancel. So you can just find the area of that trapezoid, which is 5 halves. G of negative 2 is the opposite direction. So even though it is above the x-axis, I think I heard Daniel saying this, positive y value but negative dx, so it's negative area. What is the area of that?
Negative 6.
Negative 6. Okay, so a point for each of those. Part B, find the instantaneous rate of change, also known as the derivative, of g with respect to x. So, Lily, g prime of x equals what?
F of X or?
F of x. And Francesca, now g prime of 1 equals f of 1, which is 4. Okay, this time they put a couple of coordinates on there, but it's labeled so that you didn't have to guess the y value staring at you. Okay, absolute minimum of g on the closed interval. And again, they are trying to help you. If you notice, part A, they asked you the endpoints. How many critical points do I have? Where does the first derivative, where does f, where does this graph cross the x-axis?
X equals 3.
Only once and at x equals 3. So there's my endpoints. So what's g of 3?
Yeah.
Some positive.
Something positive. Well, it's g of 4 with,
Less than or
Well-
more than -6, so.
well, right. But for the work, this is a half, right? 1 by 1 triangle with a, the half. So back up. Okay, so absolute minimum, what is the lowest of the low? Well, in my table, I found the endpoints and the value at all critical points. What is the lowest y value? The minimum? The minimum is -6. Did they ask where it happened? No, but I would say, just for grins, and the table is good enough. I don't remember what they showed as work, so let's look. So, interior analysis. So this is like, yeah, I would be irritated, but they are saying that you needed to check the inside. And I would argue that, as you just said, like, come on. The inside, the derivative went from positive to negative. That's going to be a maximum. Clearly not the issue. In, I can't remember what year this was. 99? Okay, so a long time ago. Wow. They wanted you to make sure that you checked inside, which technically we did by doing that table. Okay, the next thing, they're telling you, all right, second derivative of g, not defined at 1 and 2, which is valid because it's the slope of this graph. No slope here, no slope there. Are they both inflection points or not? Paulo, which one's an inflection point, if any?
1.
At x equals 1, why?
Changes.
What is it?
Positive, negative.
What is it? Okay, so you could, as long as we had in here somewhere, only Lily was the one who gave us this. As long as you've connected G to F in some way, for your justification down there.
And the question doesn't actually ask where, it just asks how many of the values are inflection points.
Yeah, okay,
So,
yep. I tend to be wordier, which is good and bad. So, all right, tomorrow and Wednesday, again, nothing new to do. Go through any old homework, come up with questions, maybe check the sample test that's posted, and the chapter review. And I will answer whatever questions you guys have, but test is Thursday. Cool.
We got, so.
A lot.